Good afternoon, boys and girls. This is Mrs. Loving and Mr. Gomez here to help you get started with your new unit of atomic structure. If you have not already set up your Wix, now would be a good time to pause the video and go ahead and set that up. I do want to remind you that you need to answer your questions with complete academic sentences. If you recall, all things are made up of matter. Well, all matter is made up of atoms. Matter comes in 4 different states. We have a solid that has low energy and the atoms vibrate in place. We also have the liquid where atoms flow or slide past one another and they do not have very much energy to move away from one another. We also have atoms that fly around each other and move very freely called gas. Then there is the most common form of matter that is called plasma. It is the highest energy with atoms where they lose their electrons and nuclei mix together, and this again is the most common state of matter. Matter is made up of mixtures and pure substances. Pure substances can be broken down into 2 different categories, one being compounds and the other being elements. Elements are made up of one type of atom, such as either hydrogen or carbon or oxygen or chlorine. Compounds, however, are made up of more than one type of atom, such as H2O, which is water, hydrogen and oxygen, carbon dioxide, which is carbon and oxygen, or hydrochloride, which is hydrogen and chlorine. Elements can become compounds through only chemical reactions, whereas mixtures can be created through only physical techniques.
Elements versus compounds. As you see here, you see some hydrogen atoms being added or combined with oxygen atoms, the new element. When you combine them, you get the water compound, which is, you see here, the 4 oxygen and the 2 hydrogen on the outside. To better know the elements and to really study the different types of elements, you're going to have to use a periodic table. The periodic table is broken down into 3 different categories. You have your metals, your metalloids, and your nonmetals. To separate the metals and the nonmetals, you have this purple stair step right here. And you'll be able to see it, and we'll be able to highlight it and really focus on it when you get your periodic table in class. Now, to describe the metals are shiny, malleable, ductile. They're very good conductors of electricity, and metalloids have characteristics of both metal and nonmetal. Nonmetal consists of dull, they're very brittle, poor conductors of electricity. Electrons don't move very freely through it. Now we keep talking about an atom, so let's describe what an atom is. Okay? An atom is the smallest part of an element. The structure of an atom consists of the nucleus. It's a small, dense center consisting or contains the protons and the neutrons. Then you have the electron cloud. It's an area around the nucleus, mostly consists of empty space and contains the electrons.
Now that you know the 2 main parts of the atom, today we're going to spend the rest of our lesson focusing on just the nucleus of the atom. The nucleus consists of protons and neutrons. Protons, just like the neutrons, are located inside of the nucleus. They both have an atomic mass of 1 atomic mass unit. The neutrons are neutral, meaning they are neither positive nor negative. However, the protons are positive. They have a +1 charge. In the nucleus of each atom consists of all of the mass for each atom, with the protons and the neutrons. It takes up a very small amount of space, and it only has a positive charge because there's only positive protons and neutral neutrons in there, leaving only positives.
Now we're going to look at the number of protons to help us identify the atom. If you look at the top left-hand corner, you will see a number which is consisted of the atomic number. Focusing on just carbon, look at the number 6. The 6 helps us know that there are 6 protons in the carbon. Now, which element has 18 protons? Yeah, that's argon. Argon has 18 protons because of the atomic number. Now let's look at bromine. If you focus on bromine, the number 35 is circled. That lets us know that it has 35 protons. Now let's look at silicon. Silicon has 14, identifying 14 protons. If we continue to identify these atoms, let's just focus on oxygen. Oxygen on the left has 8 protons. So let's look at the little picture. 8 protons, 8 neutrons. The one in the center has 8 protons, 9 neutrons. The one on the far right has 8 protons, 10 neutrons. Because they have 8 protons, they're still classified as all oxygen. You're probably wondering, how are they still oxygen if they all have different neutrons? Well, that's because they're considered isotopes. Atoms with the same number of protons but different number of neutrons have different masses, but it's just slightly different. But with the 8 positive neutrons, they're still classified as oxygen.
Now, looking further at the characteristics of the periodic table, we've already talked about how our atomic number is located in the top left-hand corner, and it is specifying the number of protons in the nucleus of each of these elements. However, there is also another number at the bottom of below each of the symbols for each element, and it is called the atomic mass number. The atomic mass number consists of the sum of the number of protons and the number of neutrons in the nucleus, because all of the mass is in the nucleus. You might be wondering why the atomic mass is in a decimal form. We will get to that in a moment, so just bear with us. We can use the following strategy to calculate the number of neutrons in a particular atom. And for this example, we're going to use sulfur. We know the atomic number equals the number of protons. We also know the atomic mass because it's located below the symbol of the element of sulfur. If we take the atomic number and subtract it from the atomic mass, we are left with the number of neutrons in an atom of sulfur. So for example, the atomic number for sulfur is 16. We know that because the number of protons is 16. We can subtract 16 from 32, which is the atomic mass, and that yields 16 neutrons in the nucleus of one atom of sulfur.
As Mrs. Loving mentioned earlier, that yes, the atomic mass has a decimal. So what is that decimal? If you look at the first element, or the first atom of oxygen, you see that it has 8 protons and 8 neutrons. So it gives you 16 AMU. Look at the one in the center. It has 8 protons, 9 neutrons, 17 AMU. The one on the far right has 8 protons, 10 neutrons, so it gives you 18 AMU. Now, the atomic mass is in a decimal because it gives you the average of that 16, 17, and 18 all together, and they average them out to give you 15 and 99 hundredths. Now, just to re-emphasize, an isotope is an element with the same atomic number, like oxygen has 8 protons. Each 3 of these atoms have 8 protons, but a different number of neutrons, causing a slightly different atomic weight. Now, when we get the average, again, gives you that 15 and 99 hundredths.
Now, with all this information that you've just learned about the nucleus of an atom, there are 2 different ways you can find the atomic mass of an atom. You can find the atomic mass by using the periodic table and looking down here at the bottom number below the symbol. Or, if you were given a model, you can find the sum of the protons and the neutrons inside of the nucleus, and that will yield your atomic mass. Well, that's all we have for you today. Hope it was fun. Don't forget to do your action item, and we'll be looking forward to seeing you tomorrow.